So normally economists think if you want to manage things properly, you need to apply economic principles. It's good to understand what economics is about, especially if you are not an economist. Economics is anthropocentric. It looks at things from the point of view of human, focusing on human values. Economics of water management, like all economics, is about allocation of water as a scarce resource, and the goal is to find out efficient ways of using water for current and future water use. Of course, water is a basic human need. The biggest user of water is agriculture, as we saw, which means food production depends on water, and there is a strong relationship between water, agriculture, food security, and poverty. So water is critical to food security and development. So it's good to understand how economics helps in the management of water. Why economics? Well, if you have anything scarce, you have to have a way of allocating it, and water is one. You have to think of trade-offs. How are you going to define trade-offs? What are the alternative uses? You have to know how to choose between these trade-offs, and eventually have to decide who gets how much water, directly or indirectly. But if you are using economic principles, it's mostly indirect. When we say who gets how much water, we are talking about allocation across sectors, allocation over time, and so on. Economics has a way of defining value. The way economics defines value is whatever people are willing to pay for something. So economics is the only subject that can define what value is for you in a useful way. There is no other science that can define what value is for you. If they give you a definition of value, it's not going to help you. In general, when we are talking about allocation, it's good to remember, especially water, it can happen at different levels. We are not always looking at an economy and trying to see what we should be producing and how and so on. Of course, it can be within an economy, can be local, can be regional, but it can also be transnational if it's water. In general, we can have three easy classifications. So we have competition for water across space, upstream versus downstream, like what we see in the Murray-Darling Basin here, how much water ends up in the ocean and so on, and also in the Nile Basin. Across time or over time, current versus future. Is this important here? It's important in pairs, because if you are using groundwater, what you are doing is you are using water at the expense of future use. That's what's happening. And of course, the other big issue is environmental water use versus other economic use. Why? If you care about the environment, then the amount of water in the rivers, in the environment is important, because without that water, biodiversity gets lost. So some economics, so we are talking about economics being useful for optimal allocation. And what type of allocation problems are we talking about? The simplest type is you have water, and that doesn't need doing anything, right? You just need to give it out. No, it's clean, let's say, or it's clean enough for agriculture. It's sitting there on the dam, and you want to give it to different users. That's an allocation problem. It's a simple one. Do I give some of the water to the city, or do I send it to the irrigation district, or do I send it down the river? So a very simple problem. That's an allocation problem. A slightly more complex problem where it's, well, if you are going to use that water for drinking, then you need to do treatment and so on. So the treatment costs come into the picture. You can also have cases where getting the water to someone involves higher costs, actually production costs, and you are talking about getting water or extracting water. So in that case, it's not just giving water you have, it's actually you are producing the water. I mean supplying the water. So that brings you closer to the usual production problem, right? You have a supply cost, you have a demand. Within the demand side, there can be different components. There can be domestic use, there can be industrial use, there can be agricultural use, there can be environmental use, all that. So when we say optimal allocation, we are talking in general, but whatever the use is, the main principle is you have to do whatever you do so that the net benefits of what you do are as high as they could be. So in general, the principle is, well, you should supply water in such a way that the marginal cost of water is equal to its marginal benefit. So it's a very general principle. Why is that general? Well, because you can interpret the cost in different ways. You can also interpret the marginal benefit in different ways. So why is this a good principle? Well, it means you are extracting all the net benefits from your choice of water allocation. So it's a general principle. And when you are thinking of the marginal cost, think of supplying costs, but also opportunity cost. Okay, so in economics, when we say cost, we don't distinguish between out-of-pocket costs and opportunity costs. They are all costs. That's why it gives you a good way of capturing what is involved in terms of cost. So if I have, for example, a simple problem, I have a certain amount of water sitting there, and I want to allocate it between two users. So this could be, I have a dam. There are two cities, and the cities have this demand for water, well, marginal benefit curve. It tells me how they value water, and my interest is to maximize the benefits that society gets out of the water. So when I'm allocating here, it doesn't matter where you start. But the thing is, at the end of the day, you have to allocate water so that the marginal benefit between the different uses is the same. Now, what I had given you here had marginal benefit versus marginal cost, right? But when I come here, there is no marginal cost. What's the marginal cost here?
Marginal cost is the other group's marginal benefit.
Exactly. So the opportunity cost. So if I start here and all the water was owned by user 2, when I am thinking of giving water to user 1, which means I'm moving to the right, the opportunity cost is what I am taking away from user in terms of marginal benefits. So that's how you think about it. Here's another example. We have the usual supply curve and demand curve here. This is the marginal benefit of water. That's the marginal cost of water. So let's say I'm digging out the water from a water resource, groundwater, and supplying it. So the more water I supply, the higher the marginal. And the more water I give to the user, the less value they have for it, because they have diminishing utility for the water. So the optimal supply of water is going to be where the marginal benefit is equal to the marginal cost. And if I look at the marginal net benefit, which is a difference between the marginal benefit and cost, that has to be 0, because I have exhausted all the net benefits. Let's look at a simple example. Suppose we have two users with marginal benefit values as shown. One user has a marginal benefit that's given by the first equation, and another user has the second equation. And suppose we have 10 units of water that we want to allocate between the two users. What's the optimal allocation? This one is an extremely easy case. What we want to find is an allocation that would make sure that the marginal benefit of water in the two uses is the same. And if we try to find what that allocation is, it's easy to find that it is 5 each, because if we do so, we would be using the 10 units, and what we'll be getting is that the marginal benefit of water in use 1 would be 10 less 2 times 5, which is 0. So in a way, user 1 would get all the water they could wish for. They have no need for water beyond 5 units. And it's the same in the case of user 2, because if we give them 5 units of water, then their marginal benefit for water would be 0. And the two benefits are equal. So unlike what we had in the previous slide, and here what we have is we have W2 here, W1 here. One user has 15 as marginal value for water when they have no water, and the other one has only 10. So now if we think of their values for water, when user 1 has no water, the value of extra water is 10, but it begins to decline as they get more and more water, and by the time they have, let's say, 5 units of water, it becomes 0. And if we look at user 2, if they have no water, their marginal benefit from water is 15. That's when they have nothing. But again, it declines, and by the time they have 5 units, it comes down to 0. So if we had 10 units of water, we would allocate it so that it's 5 each. Now, this is a very simple example. If we had fewer than 10, then the two lines would cross, and we would have a case where the marginal benefit values are not 0 but higher than 0, because they still have a desire or a value for more water, and there isn't enough water for both of them to have all the water they need. So we would have a case where we would have the two curves crossing. and the allocation would equalize the marginal benefit values, but the marginal benefit values would be above 0 because there is a shortage of water. Here is another exercise where we want to know the aggregate demand for the two users. To be able to do that, we should first find out what the individual demand curves are, or in fact the marginal benefit values are actually the demand curves. And the reasoning goes like this, because if we have the marginal benefit values that people or a user gets from water, that benefit value is the upper limit to what they are willing to pay for water. And demand is about value or about willingness to pay. So in a way, this is telling us what they are willing to pay for water, because the maximum they are willing to pay for water is what the water is worth to them, and that value of water to them is measured by the marginal benefit. So the marginal benefit curve itself is the demand curve for water. So if you think of what the user would buy, if you told them what the price of water is, so if we had this vertical axis now measuring the price of water, then that line, the marginal benefit curve, would give you the demand for water. So if we know this much, then getting the individual demand curves is simply a matter of saying, well, if the marginal benefit is known and it's like this, then we could write the demand simply as 10 minus 2W for user 1. And by the same reasoning, for user 2, we would have, again, the individual demand being 15 less 3W. And of course, we are writing the demand curves the way economists write them when they draw curves, where the price is on the vertical axis and the quantity, in this case water, is on the horizontal axis. If we want to get the aggregate demand curve, on the other hand, we need to think in terms of how much water they are willing to buy. And an easier way to think of that is, well, to think of a price and then find out what each user is willing to buy. To do that, it's much easier to invert the demand curve function so that we have W, or the quantity, on the left-hand side and the price on the right-hand side. So if we take the first user's demand curve, we can write the demand curve for the first user. If we rearrange this equation, is such that the water they would require, that's the demand by user 1, is equal to 10 less P over 2. This is based on simple rearrangement, but that's simply, if we simplify it, is 5 less P over 2. So that's the demand curve for user 1. And the demand curve for user 2 would be, by following the same procedure, we would know that it is 5 less P over 3. Now, I have two demand curves. I can go on and find out for any given price what they are willing to buy individually and in aggregate. And that becomes easy if I think of the aggregate demand for water as W without any subscript, which means it's the sum of water demand by users 1 and 2. Then what I would have is, I would have 5 and 5 here, 10. And if I add P over 2 and P over 3, I have the aggregate demand curve. But if I simplify this a bit further, I would have 5 over 6 times PB being what I need to subtract from there to get the aggregate demand curve. And if we go back to the example where we had 10 units of water, and the marginal value, once we have allocated the water between the two of them, was 0, well, if you put a price of 0 here, you would get an aggregate demand of 10, which is consistent with that. So this is the aggregate demand curve. It works in general, not for just this example. And that's how we aggregate demand. We look at a price and find what the different users are willing to buy at that price. And the sum of those quantities that they are willing to buy is the aggregate demand.